Okay, so what I'm going to do is I'm going to go through the notes like I did last time, and then I will try and put up a video individualistic, somebody else talking. They're probably better than I am sometimes at this stuff, so hopefully it'll help you understand a little better. So we're going to talk about two more proving things. If you have ASA and AAS, so we're going to start, I'll talk about them both on this one. Like I said, and I'll put up an individual one for each one. We'll only talk about one the first day. We'll talk about the one the next day. So, ASA, it stands for what you think it stands for. Angle, side angle. Once again, just like with SAS, notice where the side is. It is between these two. Right? So to use angle, side angle, it has to be an angle, then the side, then the angle. It can't be side, angle, angle. That's actually the next one. So make sure you're using the right one when you write your answers down. So, we'll do this proof right here because proofs are fun. So we have our given, right? I'm not going to waste time writing it down. It does mark our angles in here, and I don't want to draw it like that because I can't see where I'm looking at. So this stuff is right there. So ADB is this angle to this angle, and then BCD, which is this angle to that angle. Okay? So I'm trying to prove ADC to BCD, right? Okay? So we're going to look at this. Well, already the tips are marked congruent. And then, if you remember angle addition, since those angles are already congruent, I can actually take AD... Well, I need more space than that. Angle ADB, ADB, and if I add ADC, that would have to be congruent to these two angles over here added together, which are angle BCD plus angle BCA. Right? I'm going to need to move this. It's right there. My given goes there still, right? Okay. Then, and this is not, this would just be addition, sorry. Angle addition would be this one. Because now I know that angle ADB plus ADC equals, let's see, ADB and ADC is this one, so it actually equals angle BDC, right? And then I can do the same thing with this bottom one. I'm just going to copy it because it'll be easier. And that is equal to DCA. And then the next step after that is, once again, if you think about it, this bottom is shared for both triangles. So my next step will be a reflexive, because CD are congruent to CD. Then, if we look at them individually, I have this triangle to this triangle. I've just marked these. These angles were given to us, and we just said these two. That's what these two were, right? So now you see we have angle, side, angle, which I guess I could have actually written angle, side, angle, angle, side, angle. Technically those angles should be switched around, but it doesn't matter. Angle, side, angle, and I can do my proof statement. Okay? So that's one of the, like I said, we'll do lots of practicing on this. Okay, the next one is AAS. So it's angle, angle, side. Notice how it has an angle here, then an angle here, then a side, angle here, then a side. So We'll do this one. AB is congruent to AD. AC is perpendicular to BD. We've done one similar to this already. Oh, I know how I want to do this one. Okay. So, first off, we know that okay, so wait. First off, we start with what? Given. Okay. Then, all that technically tells us is that ACB and ACD equal 90 degrees. Because that's what the definition of perpendicular says. But, if two things equal the same thing by the transitive property, those two angles have to actually be equal. Oops. Then, in order to do angle side, which is what I'm trying to do here, obviously, I actually mentioned something a while back that if sides are congruent, like these two sides are, then the angles opposite those sides have to be congruent. So by the definition of isosceles, angle B has to be congruent to angle D. Technically, I might be skipping a step there. I'll give somebody points if they can tell me what step I skipped there. Okay? Mention notes 4 or 5, which it says the wrong one at the top, but that's okay. So now with this, in this triangle I have an angle. Actually, no, I have an angle here. Let me do colors. I have an angle here, an angle here, and a side. An angle here, and a side. Actually, that was backwards. Angle here, side. So now I have AS, and I can prove my triangles congruent. Okay? That's all I'm going to talk about on this one. If you have any questions, you can email me like usual. Swing by and see me. I'll be happy to help you. Otherwise, have a good evening, and I will see you soon.